Here is our first example. Pauline mows a lawn at a constant rate. Suppose she mows a 35 square foot lawn in 2 5/10 minutes. In solving this problem, let's first remember what constant rate means. To say that a rate is constant tells us that the average rate of change, in this case, the amount mowed divided by the time elapsed at any moment in time, is always constant. So C equals that rate is the same for the amount mowed divided by time elapsed for any time. Our first question asks, what area in square feet can she mow in 10 minutes? I'm going to begin by annotating my question. Suppose she mows a 35 square foot lawn in 2 5/10 minutes. Well, that means that my constant rate can be written as 35 square feet divided by 2 5/10 minutes. Now, in this problem, we're asked what area can she mow in 10 minutes? So let's write a variable for that. Let's let area A be the area mowed in 10 minutes. Because I have a constant rate, I know I can write the same equation, C equals, for my area divided by my time, 10 minutes in this case. So I know that C should also equal A square feet divided by 10 minutes. Now, because both of these ratios or proportions or rates should be the same value of C, I will set them equal to each other. That is step 3, setting up the proportion. So I will take my 35 divided by 2 5/10 and set it equal to my A that I don't know divided by 10. Now we're going to solve this proportion. And we solve proportions like this by cross multiplying. Remember, my goal is to find the value of A. To do that cross multiplication, let's take the 35 and multiply by the 10, the left numerator multiplied by the right denominator. So we get 35 times 10. We're going to set that equal to the left denominator multiplied by the right numerator. So 2 5/10 times A. Now I want to isolate A. That is the variable I'm seeking an answer for. What is the operation I use when I have something multiplied by my variable and I need to know what my variable is by itself? That's right, we're going to divide. Dividing both sides by 2 5/10. I notice now I have A by itself, so A equals this value, 350, that's the product of 35 and 10, divided by 2 5/10. I can convert this fraction into a single whole number just by multiplying the top and bottom by 2, which is 700 divided by 5. And then I realized 700 divided by 5, that's a math problem I can do more easily. I got that the area was 140 square feet. So in writing a complete answer sentence for this problem, I would say she can mow 140 square feet in 10 minutes. And that is what my final answer would look like. Now we're going to find what happens in T minutes. First, we'll define a variable. We need an area for when we've mowed for T minutes. So I'm going to let that variable be Y. We're going to let Y be the area mowed in T minutes. And now once again, I'm going to set up a proportion because I know that this constant rate at which she is able to mow should also therefore be equal to my Y divided by T. If it's constant, amount mowed divided by time should be equal no matter what that time is. So let's set this equal to the ratio that we do know. the rate of mowing over the first 2.5 minutes. So I'm going to set that equal to 35 square feet divided by 2 5/10 minutes. That is my proportion. Our next step now is to do the cross multiplication. Cross multiplying here, 2 5/10 y equals the denominator from the left times the numerator from the right. So 35t. And now by dividing both sides of the equation by 2 5/10, I get an expression for how much has been mowed in t minutes. It will be 35 divided by 2 5/10 multiplied by t. So we can say we can mow 35 divided by 2 5/10 t square feet in t minutes. And that 35 divided by 2 5/10 is an important value. It is the constant rate. And the second question that we are asked, write the two variable equation that represents the area of lawn that Pauline can mow in t minutes. Well, we just solved it in answering the second part of question 1. Y equals this 35 divided by 2 5/10 times t. Let's look at how it helps us to have this equation relating y and t. Using the linear equation from number 2, we're going to complete the table to determine how much area of lawn Pauline will mow in 1, 2, 3, and 4 minutes. And then we're going to graph that on the table in the coordinate plane. So we're going to look at t's of 0, 1, 2, 3, and 4. Using our linear equation, y equals 35 divided by 2 5/10 t. If you divide 35 by 2 5/10, that's the same as dividing 70 by 5. I obtain that again by just multiplying the numerator and the denominator by 2. And so I actually can simplify this equation and write this as y equals 14t, which is a little more helpful when we're doing our mathematics. Let's model the linear equation we have above with each of these values plugged in. So at 0, we have y equals 14 times 0 minutes, and we get 0 square feet. That makes sense. If she isn't mowing for any amount of time, she shouldn't mow any lawn. If we allow her to go for 1 minute, 14 times 1 minute, which would be 14. Over 1 minute of time, she is able to mow 14 square feet. If we go for 2 minutes, we're going to replace t with 2 now. So 14 times 2, and we get 28 square feet. Next, if we look at y equals 14 times 3, so what the equation would be when our t is 3, 14 times 3. Let's do that on the side over on the far right here. 3 times 4 is 12. 3 times 1 is 3. Add 1, we get 4. So we're looking at 42 square feet of area mowed over the first 3 minutes when she mows at this constant rate. Last, when y is 4, we have y equals 14 times 4. And that is 56 square feet. So now I'm going to plot each of these points. Remember the t coordinates, it's my horizontal movement. So at time 0, I would like to plot the point 0, 0. That's right down in the bottom right corner of my screen there. Next, I'm going to look at 1, 14. So I find the vertical location at 1, and I'm going to travel up to 14, which is about there in the vertical direction. Then we can do 2 and 28. 2 travels all the way up to 28. Should be about there. 3 and 42. 3 goes all the way up to 42, which is just a little shy of halfway between 40 and 45. And 4 and 56. So that's when we have to go just a little bit above 55. Now notice something about these points. Granted, I was a little uncareful. I did it by hand. But watch what happens when I line them up with a ruler. Do you see that they all land along the same line? We have the same amount of increase as we move to the right 1 unit. That increase is always 14 units. That's where we see the constant rate showing up on the graph.